Number 44. There are two molecules with the formula C3H6. Propene, which is CH3 with a CH that's double bound to a CH2, is the monomer of the polymer polypropylene, which is used for indoor-outdoor carpets. Cyclopropane is used as an anesthetic, so it'll put you to sleep. That's this guy right here, cyclopropane. Cyclo always means that you have some sort of ring, and in this case with 3 carbons, you make a triangle. Now, when heated to 499 degrees Celsius, cyclopropane rearranges, which means that it isomerizes, and forms propene with a rate constant of 5.95 times 10 to the negative fourth to the seconds minus 1, so per second. What is the half-life of this reaction? And then they ask another question, but first we'll tackle one question at a time. They asked us what the half-life of this reaction is. Now, anytime that they're asking for a half-life is denoted by T and then a little 1/2 as a subscript. Now, a half-life is just the amount of time it takes for a certain substance to decrease to 50%. So, in this case, if we had, 100% sample of whatever we're talking about here, right? The cyclopropane, which is this triangle guy. Why did I put degrees Celsius? Nobody knows. But if you have a 100-degree sample, did I say degrees again? I don't know. I was outside. I was having fun outside earlier. It's getting nice here, so try to take advantage of the nice weather. But anyway, if you have 100% of your compound, whatever it is, and it goes down to 50%, that specific time that it dropped by, 50% of what it was in the beginning, that's a half-life. So that's a T-half. And then if you take your sample and you drop it down another 50%, aka you divide by 2. So this would be 25. That's another half-life. So there's a misconception out there that basically you have a compound or a pharmaceutical only has 2 half-lives, right? One to take it down to 50 and then 50 down to 0. However, whatever you're starting with, that's your new initial value. And you go half of that. That's a half-life. And then if we did another half-life, you would split the 25 in half. So 25 divided by 2, 12.5. That's another half-life, and then so on and so forth. So in this case, we just want to find out what that half-life is. Now, for these, right, with your kinetics, you should know formulas for 0-order reactions, 1st-order, and 2nd-order reactions. Now, if the question was nice to you, they should tell you what order this reaction runs through, right? But if I'm looking, through this question again, it doesn't say anything. Doesn't say that cyclopropane undergoes 1st-order kinetics or 2nd-order or 0-order kinetics. So how am I going to know which equations we're going to use? The answer lies in the rate constant. Now remember that the rate constant is a tricky one because a rate constant will have different units depending on what order your total order is. Now if you have your rate constant, which is a K value, if your K units are time to the -1, just time, no molarity, no pressure, no nothing. It's just a time to the -1. So seconds to the -1, hours to the -1, minutes to the -1. If your units are only time to the -1, you know that you're dealing with the 1st-order reaction. So if they do not tell you, or if the question does not tell you what order you're in, chances are you're going to have to look at that rate law. Look at those units and say, hey, it's only a second to the -1. That's 1st order. So now since I identified that, now I can bring in the 2 1st-order equations. Now in this case, they just want us to find out the half-life. Out of the 2 equations, there's only one that deals with the half-life, and that's this one. So maybe I'll bring this up. Whee! A half-life for 1st-order is always equal to 0.693 divided by K. And in this case, we know what the rate constant is, right? That's the K value, the rate constant. So all we have to do is just plug it in. My half-life would be equal to 0.693 divided by my rate constant, which is 5.95 times 10 to the negative fourth. Maybe let's just get rid of this. Goodbye. And let's solve for half-life, right? Half-life is going to be the time it takes for this to decrease by half. So 0.693 divided by 5.95 times 10 to the negative fourth. Everything looks good here. 5.95, everything looks good. Press enter. Whoa! 1,164.7. So maybe I'll just put it in scientific notation. 1.16 times 10 to the 3. And now what's the question? What are the units here? Is it minutes, hours, days? Well, it always goes by the rate constant units. In this case, they gave us as a rate constant as seconds, right? Seconds to the -1. That's the time value. Only pay attention to the actual time unit. You don't have to worry about the -1. But in this case, all half-lives, all time, they're going to be either seconds, minutes, or hours. So in this case, it would be 1,160 seconds. Didn't say that we had to convert that, so I'm going to leave it like this. But if you needed to convert to minutes, you just divide by 60. If you need to convert to hours, you divide by 60. But you get it. Color. Oh. Always makes me a little bit upset when I overshoot my highlighting skills. But as I'm getting older, my hands are not as, I guess, what is that? My hands basically go all over the place. But anyway, we found out the first answer. Now, let's do the second one. What fraction of the cyclopropane remains after 0.75 hours at 499 degrees Celsius? Okay. So now they're talking about amounts, right? What fraction of that propane remains after 0.75 hours? When you're talking about now dealing with amounts, you're now coming into the realm of the other equation. So for these integrated rate laws, you will have one half-life equation for every order, 0, first, and second, and then you'll have one integrated rate law that talks about initial concentrations and final concentrations, or initial amounts and final amounts. Now in this case, they want us to know what fraction remains. That's the remaining amount. Now in general, with this equation, you have two amounts. Your A0, this little 0 means that no time has started, 0 time. This is always your initial amount. And could be a percentage in here, could be concentration, could be a fraction, right? It doesn't matter. Initial amount, whatever it is. Could be grams. This one, without the 0, this is your final amount. So that's what we're solving for. We want to find out what fraction remains. And now they're telling us specifically that we have to work in fraction form, which is totally fine. But we're still solving for x here. Now, if we go back to this, what I did before was I did the percent route, right? And we talked about 100% was the initial, 50%, 25%, 12.5% as you keep dividing by 2. But now if you want to go the fraction amount, we have to say to ourselves, well, what's the highest fraction that we could possibly have? What's the initial fraction? Well, it's 1, right? Because if you have, let's just say if you had 8 slices of pizza total, and you didn't touch any of those slices, you still have 8 left. 8 divided by 8 is 1. If you have 4 slices of pizza and you didn't touch any, 4 divided by 4 is 1. So the highest fraction, your initial fraction, is not really a fraction at all. It's number 1. And same exact idea. Now you're dividing by, 2 or timesing by a half. So 50% is the same thing as saying 1 over 2. And this would be a half-life. And then if you cut it again, now you're taking your half, cutting that in half, going to another half-life. That's 1 over 4, which is 25%. And it keeps going and going and going. So my initial amount that I'm going to use here is I'm just going to use 1. Because that's always, when you're talking about a fraction form, the highest fraction is 1. The K value we found out, well actually we didn't find out, right? The K value was what they told us. They told us that it was 5.95 times 10 to the negative fourth seconds to the minus 1. And now this time, lowercase t, this does not have that subscript half, which means that this is the time that we're looking for in the problem. When it says what fraction of the cyclopropane remains after 0.75 hours, that's the time that we want. But now hold on, because we just have to make sure that those time units, they're the same. But the rate constant's in seconds, and the actual time that we're looking for is in hours. So the first thing we're going to have to do, I'd like to just transfer the time units over. I don't really like to touch the rate constant here. So instead, I'll just take my hours and go to seconds. Now, how to go from hours to seconds? Well, divide it by 60 and then divide it by 60 again. You can also divide by 360. But either way, you'll get the same answer. So if I take my 0.75, just kidding. Christina. We times by 60 because we're going from hours to seconds. So times by 60 to get to minutes, times by 60 to get to seconds. So now let's try it again. 0.75 times 60 and then times 60 again. Oh yeah, 270. And that's the seconds that we're going to use. All right, let's use our formula. ln of x equals negative those two values, and then I'll say plus ln of 1. Okay, so the K value was 5.95 times 10 to the negative fourth, and then my time was 270. Now, if you have a TI-84, which I have over here, love my Calci, we could plug all this in one shot. So that's what I'll do. But if you want to break it down, you can. You should get the same answer as me at the end. So let's see. Negative 5.95. Don't forget that negative because that's part of the formula. So negative 5.95 times 10 to the negative fourth times 270. Looks good to me so far. And then plus ln of 1. Close the parentheses. Okay, so we had ln of x equals negative 1.6065. But now we just want to get x. So we have to do the inverse. That's the e to the. E raised to the ln is inverses of each other, so they cancel out. But whatever you do on one side, you got to do on the other. I'm going to say second. Raise it to that value. And now I get this. So x equals 0.20. I guess we'll say 1, but I mean, very close to 0.2. But now the thing is, they wanted a fraction. When we're doing the math, this is the decimal version. So if you want to, we could just say, what is the fraction that gets us to 0.2, right? 0.2 is 20%. So what would that be in fraction form? Well, if you think about it, 20%, if you have 5 20s, that equals $100, right? So if you have 120, you only have 1 out of the 5 components. So the fraction form here would be 1/5. Or very, very close to 1/5. If you want the exact amount, it's going to be that 0.201. But if they said, specifically what fraction remains, we're just going to round a little bit, and 0.2 is 1/5. Let's color this in, and I'll show you another way. Let's see. We might have to generalize here, but we'll see what happens. Now, on the calculator, you might be able to get away with seeing what this is in fraction form. So I think what we do is we press math. Here it is, FRAC, fraction. So I press enter, and let's see. Yeah, it didn't, because there's a lot of decimals here. But if you just take your, closest value, so 0.20, right? So if I say 0.20, now I do my math. Let's see if it'll give me the fraction. There it is. So with this way, just make sure that you have just the one number rounded. And that's it. What'd you think? I hope this helped. Let me know in the comments. Love talking to you guys in my spare time. I love trying to get to you, as much as I can. Thank you so much for all your support, and I'm so glad that these videos are helping you out. Click the like button, tell your friends, tell your classmates, just get the word out there that this channel exists. And I appreciate you guys so very much. Thank you. And I'll talk to you soon, okay? All right, bye-bye.